We have started with analysis and design of the column. So column is a vertical compression member whose effective length is more than 3 times its lateral dimension, and the main function of the column is to transfer the load of superstructure to the foundation, and depending upon the architectural requirement and the loading condition, the column may be cast into different shape. The shapes used are, the first one is the square shape. Here the B is the width of the column and D is the depth of the column. So in case of the square column, this depth D is also equal to the B because the dimension in both the direction are the same. The second one is the your rectangular column. In case of rectangular column, here the B is the width of the column and D is the depth. Here the third type of the shape used is the circular type of the column. In case of the circular column, the diameter, suppose D is the diameter of this circular column. So these are the different shapes are generally used in the residential building. And again, in case of the multi-story building, the L-shaped columns or the T-shaped columns are to be also used one, depending upon the loading condition and the architectural aspect required. The next one is the classification of the columns. First one, we are going for the classification of column based on the types of reinforcement. First one will be the column reinforced with longitudinal steel and lateral tie. Lateral tie is nothing but your stirrups. So here these are the longitudinal steel bars and this is your lateral tie. This is your stirrups or the lateral tie. So this is the column with longitudinal steel and the lateral tie. These are generally used in case of the square or the rectangular type of the column. Then second one will be the column with longitudinal steel and closed is placed a spiral. So here this case is generally used in case of the circular column. So this is your longitudinal steel bars and this is your spiral. So this is the spiral and these are the longitudinal steel bars. So these are generally used in case of the circular column. The next type of the column will be the composite column. In case of the composite column, instead of longitudinal steel, we are using the steel section, just like I section, T section or the channel sections are to be generally used one. So this is your steel section and these are again the lateral tie or the stirrups. Then the column is called as composite column. The next type of the column is the steel pipe fill up with the concrete. So this is are the classification of the column depending upon the types of reinforcement provided. The next classification will be based on the types of the loading. So first one is called as the axially loaded column. So axially loaded column is nothing but the resultant load acting on the column will be coincide with the CG of the column. So this is the load acting on the column and this is the CG of the column. So both are the loading will be coincide with the CG of the column. Then column is called as axially loaded column. Then column with uniaxial eccentricity. So in this type of the column, the eccentricity will be along any one of the axis. So here the E is the eccentricity of the column along the x-axis and P is the resultant load acting on the column, and this is your centroidal or CG of the column. Then third type of the column is the column with biaxial eccentric loading. In this type of the loading, the load is in this type of the column, the load will be the eccentric along with both the axis, that is this will be along the x-axis, Ex is the eccentricity along the x-axis and Ey is the eccentricity along the y-axis. So this is the second type of the column based on the types of loads. Then third will be the based on the slenderness ratio. This slenderness ratio is nothing but the slenderness ratio is nothing of the compression member is defined as it is the ratio of effective length to the least lateral dimension of the column. So slenderness ratio is effective length divided by least lateral dimension. Depending upon the slenderness ratio, the first type of the column will be the short column. So short column is nothing but if the ratio of L effective divided by B, that is least lateral dimension, is less than or equal to 12, then the column is called as the short column. And second will be the long column. If the ratio of L effective divided by B, that is least lateral dimension, is greater than 12, then the column is called as the long column. So these are the classification of the columns depending upon the types of steel used, depending upon the types of loading and depending upon the slenderness ratio. The next important one is the calculation of the effective length of the column, because for deciding whether the column will be the short column or the long column, or for designing purpose, we are required the effective length of the column, because the design procedure for the short column will be the different, design procedure for the long column is also different one, and also the load carrying capacity of the short column and long column will be the different one. So first we have to go for the calculation of effective length for the column. For that, IS 456-2000 will be defined how to find out the effective length, and this effective length will be depend upon the different types of the support condition that we are providing for the columns. For that, you have to refer the table number 28, which is available on the page number 94 for calculation of the effective length. Then first one will be the support condition. If your both ends are the fixed one, that is rigidly fixed one, in that case L effective, that is effective length of the column, will be 0.65 times L. L is the total length of the column. Then second condition, fixed at one end and hinged at other end, that is one end is rigidly fixed against the rotation and one end will be the held in the position but not restrained against the rotation. It means we are providing the hinge support. In that case, L effective is nothing but the 0.80 times L. Then third one, both ends are the hinged one. In that case, L effective is equal to 1 times L, that is total length of the column. Then fourth one end fixed, other is to be free one. In that case, effective length will be the 2 times the length of the column. So this effect. Then next one is the restrained against rotation at one end and other end is restrained but not held in position. In that case, L effective is nothing but the 1.2 times L. So these are the different formulas that we are used for the calculation of the effective length of the columns, and which is very important for analysis and design of the column. The next one is the reinforcement, which type of the reinforcement that we are providing in the column. So first type of the reinforcement we are providing, that is the longitudinal reinforcement, that is also called as the main steel. The longitudinal bars or reinforcement is provided to resist the compression in combination with the concrete, and it is also used to resist the tensile forces that will be developed in the column, and also used to reduce the creep and the shrinkage effect of the concrete. And this generally what we are doing, we are providing this columns longitudinal steel exactly at the periphery of the column. So these are the positions of your longitudinal steel that we are providing exactly at the periphery of the column. The next type of the steel we are providing, that is the transverse or the lateral reinforcement or the stirrups. The transverse reinforcements are consist of separate small diameter steel binders bar. Generally what we are using the 6 mm or the 8 mm diameter bars as a transverse or lateral reinforcement, which is also called as the stirrups. Now what is the functions of this transverse reinforcement? First function is to prevent the buckling of the longitudinal bars. It will be keep intact all the longitudinal bars in the position. The next one, to resist the diagonal tension developed in the column, to prevent the long splitting of the concrete. So these are the main function of the transverse reinforcement. Again, we have to refer IS 456 clause number 26.5.3.1 page, which is available on page number 48 and 49 for the detailing of longitudinal and the transverse reinforcement. The next one is the difference between the short column and long column. So first one is short column is nothing but the L effective divided by B, that is the lateral dimension, least lateral dimension, then which is less than 12, then we are getting the column is classified as a short column. Then if the slenderness ratio will be greater than 12, then the column will be termed as a long column. Then buckling tendency is very low in case of the short column, because the short column will be carry the more load as compared with the long column, but long column will be buckle easily. The load carrying capacity of the short column is very high as compared with the long column. The load carrying capacity is less as compared with the short column. Failure is due to the crushing here in case of the short column, but in case of the long column the failure is due to the buckling of the column. Then again the important, that is the radius of gyration, that already we know. The radius of gyration of given area is about any axis is the distance from the given axis at which entire area is assumed to be concentrated without changing the moment of inertia, and this is the formula used for calculation of the radius of gyration. So this is about the theory of the column, that is what is the short column, what is the long column, then type of the reinforcement used in the column, that is longitudinal reinforcement, and the lateral or transverse reinforcement that will be used in the columns.